Hello and welcome to the Someone YouTube channel. My name is Ray, and in this video, the Raspberry Pi Robo hat part 3, we're going to continue on with its design. So in the last video, I had basically covered off all of the first board with the NPR 121, the PCA 8574, the two ADS 1115s, the PCA 9685 16 channel servo driver, a level shifter for I2C bus, and the MPU 6050, as well as the requirements for being called a hat, the ID chip and the header. And I mostly designed the board. I'll come back to the board in a minute because I did have to rearrange some of the components on it. On the second page of the schematic, this is the diagram for the daughter board. We've got our single power connector for the servos, and this is the only source of power for the servos, and it only feeds the servos. And what I've done is I fed to the top of these resistors, or supply into each of these resistors. These resistors are a 0.1 ohm resistor. I think in the original diagram bits I was saying to put together in the last video, I actually had it at 1 ohm. Testing has shown that I really need 0.1 ohm, and it works quite fine at 0.1 ohm, which is actually better for our servos anyway. I described at the end of the last video a group of 4 servos where I was going to have 2 servo connectors linked to one of these resistors, and the other two, one of them would be connected to the second, and this third one here had the option of being one or the other. By default, this board will set it up as pairs, but my first real application will be in a robot dog, where I'll split it and run a group of 3 and a group of 1. So what I've got are my INA 219 chips, and each one is configured for a different address. I've used the first half of the address space that it can use, and that's because the start of the second half is where my ADS 1115s sit. They only use 2 of the addresses, but it's just easier to stay clear of it all. One of the things I did do in the schematic is I actually updated some of the info on the page to tell you what the address is for the device. In the case of the PCF 8574, because there's 2 variants available in the chip, I've actually listed the address for both the variants. So if it's got a T on it, it will be the higher value. So this drawing shows a T on it, so it'll be 0x38. If it hasn't got the T on it, it will be a 0x20. So some of the breakout boards that I've been testing with, in fact all of the breakout boards I've been testing with, are at the 0x20 address. But if I go with the T variant, it'll end up on this higher address range. And choosing which one I go with very much is dependent on price and availability. Okay, so let's have a look at our PCB when I find it. So this is the PCB for the servo connections, and I think that's because I've highlighted a page. See if that yeah, I'm not sure what's going on there. It's decided to change into a funny mode. Alright, so what we're going to look at here is first off this board on the left, and it really is a pain, that. It's not letting me select properly. There we go. I deselected. Oh, not quite. Still got zoom in that. That's better. Okay, so what we've got on this board is I've moved this connector between the hat and the daughter board, or its daughter board, from down here up here, and rerouted all the connections. I also moved from this area, the MPU 6050, which I had up here, is now right down here, out of the way. I moved these down from up here down a bit and shifted the ID EEPROM across this way. So that's all fine. The blue circles here are the pads on the underside of the board, here and here as well. That's voltage. I've got a ground and I've got the right protect. And that's so we can use pogo pins to program our ID chip as well. I could add more of those for testing down the track if I wanted to. I may do that, but I don't see the need at this stage. Things I can still change further is moving the MPR121 chip up into this area. It'll make these traces shorter for a start, which is a good thing, and allow me to bring this down, rotate it, and put it down in this area. And the PCF8574 chip can come down this way as well, and that leaves a bit more room there for anything else that I want to put in. Although I don't know what else, maybe some of my viewers can make suggestions. So that was the rearrangement so I could get this header up further. Okay, so let's have a look at the other side. Whoops. So this is the servo board. Essentially, it's the daughter board that carries all of the servo plugs, the power for the servos, the resistors we need for voltage drop to tell how much current's flowing or how much power's flowing, and the 8 INA 219s, which are here. Now, this can be difficult to read and look at, so how about we have a look at this as a 3D rendered view. I know what I've done wrong here. How about a whole board selected? Here we go. So now I can look at individual components. So what we have is our servo boards, our servo connections for each of our servos. I would have liked to have them closer together, but it does actually trigger design rule errors. It is something I'll look at in the future. I haven't found the component available yet that is a group of 4 servos at right angles. If I could find that, and I know they exist because I've seen them on a few components so far, like a few boards that I've purchased. So I know it exists as a component, I just haven't found where to get it. And we've got our INA 219s. So I've started at the base address for one of these, and I've just gone up each increment in the addressing. So 12, 13, 14, 15 are there. This is the header that goes to this plug here, and if I flip the boards, you can see it on the other side of the board. I've run the ground for the most part on the underside for the between sections. I come to the top here. I could run it on both sides if I wanted to. For the ground, it doesn't hurt. The main power bus is through here that feeds all of these power resistors. Now, the way the INA 219 works is it measures the voltage on the supply, so it measures this voltage. It then also measures this voltage down the bottom and compares the two. And the difference is the voltage drop across the resistor. And if you know the value of the resistor, in this case 0.1 ohms, you can calculate out the current flowing through that resistor and therefore the power in milliwatts in this case. The good news is it's been tested now. Personally, I've tested it and I know that it works within my robot lab, so that's really handy to know. You can see here the NPU 6050 down the bottom corner here. So if you look at a Raspberry Pi and see if I can find one out, hurry. So this is a Raspberry Pi 3. If we mount it up this way, our board would come down, so our touch inputs will be down here. The CSI camera interface is here. So at the moment I've got the PCF 8574 connector around this area on my board, and over this side is where all my analogs are. So if I can move all of the PCF ports down here, that would be better, and my touch inputs are here. So that'll be handy. 8 of my servo ports will be down this side, and the remaining will be on this side, going over the top of my connectors. So when inside a tightly confined area like in the Spot Micro project, all of my connectors etc should either be clear of the outside edge going into the robot or over the top of my USB and network ports on the Raspberry Pi. So that'll do for this video. If you like these videos, don't forget to click on like, subscribe and ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account and you can join my VIP patrons Go Lucky and Lorenz Berger, and my Builder patrons Elmer Else 45 and White Wolf in supporting the channel. All of my patrons do get these videos at least a week early compared to YouTube. I also have my Discord channel, of course. If you've got any questions, feel free to drop into Discord and ask questions if you have any, or let us know what you think. And we'll see you in the next video.